Well, hello there. So in this video, we're going to be looking at Monopoly practice problems, which would be coming from Extra Practice Module 61. So for the first one, it says use the accompanying total revenue schedule for Emerald Incorporated, a monopoly producer of emeralds, to calculate the items listed in A through D, then answer part E. So for part A, it says the demand schedule, and then it gives you a hint. The average revenue each quantity indicates the price at which. Okay, so that's one way to do it. There's an easier way I think to do it, but maybe it's I think they're actually telling you the same thing. So they just want us to do a demand schedule. So we have quantity demanded and price is a demand schedule. That's all that is. And they're also giving us total revenue already. So and we have 5 units. So 1, 2, 3, 4, 5. And they give us 100, 186, 252, 280, and 250. So their TR falls there. And so really we just know that like price times quantity gives us total revenue. So we know the price of the first one has to be 100. 2 times something gives us 86. So that's 93. 3 times something gives us 252. So that's I knew I had a calculator for a reason on this one. Woo, 252. And I think this is actually what they were telling us with the hint. 84. And then, yeah, that would be much easier, right? If I followed my own, hey, you got the calculator out. Number 4, that's 70. That should be easy. And then this last one is 50. So that's our prices and our quantity demanded. So we've done part A. Part B says the marginal revenue schedule. So that one's actually relatively straightforward as well. There isn't one for this. Well, the first one actually is 100 because the 0th unit is the one where there isn't one. So the change in total revenue, right? So we'll just write that change in total revenue over change in quantity. And so this is the change to the next one is 86. And then the change to the next one is, let me do this here, 252 minus 186 is 66, and then that's 28, and that's negative 30. And then it says for part C, the quantity effective component of marginal revenue at each output level. So that's just a fancy way of saying by selling an additional unit, how much more like of that marginal revenue how much more marginal revenue did you get? Like as a result of selling an additional unit. And so that actually, this is kind of weird, but it's basically the same as the price. So I don't know why they're going through that process, but like by selling the second unit, you're gaining 93. And that's the idea of the quantity effect is like how much did you gain by selling an additional unit, right? So we'll say for that one it's 93. By selling the third unit, you gained 84. By selling the fourth unit, you gained 70. By selling the fifth unit, you gained 50. And then it says the price effect for the next one. And I guess I understand what they're trying to get you to think about here is like, why does price and marginal revenue, why are they not the same thing? Because the price effect is saying by lowering the price when you go from 100 to 93, 93 to 84, 84 to 70, 70 to 50, you're giving up some revenue as a result of that decision, right? So on one sense, you're gaining some revenue by selling an additional unit, but you're also giving up some revenue because you're cutting the price of the previous units that you sold already. And so this is trying to get you to see like that, those two forces coming together and conflicting each other, right? And so realistically, the difference, the idea here, and that's actually just supposed to be 80. No, that's 186. I just can't read. What we can actually figure out, the idea here is that the quantity effect is saying you're gaining 93 by selling the second unit. Well, we know that at the end of the day, we only got 86 as a result because that's the marginal revenue. So what happened here means we had to lower the price by 7, the difference between the two, and that's what caused that marginal revenue to be 86. So we lowered the price by 7 when we went from 100 to 93. So this is negative 7. And then for the next one, in thinking about this, it's not like how much did you lower the price of just that second unit by, but in fact, you had to lower the price from 93 to 84. That's 9, but you had to lower it on the second unit and on the first unit. So this is negative 18 for the third unit. Now, another way to think about this is just actually look at the difference between the quantity effects is saying you're gaining positive 84, and here it's saying you're gaining positive 66 for the marginal revenue. So something had to be dragging us down to just 66 for that third unit, and it's the negative 18. That was a result of you having to cut the price by $9 on the second and the first unit when you go to the third unit. So again, there's really two ways to look at this, right? We could say 84 to 70, well, that's 14, and we had cut the price on the first, the second, and the third unit by 14. So 14 times 3 is 42. Or we can actually look at the quantity effect, which is saying you gain 70 here, but you ultimately only end up with positive 28, and so this must be negative 42. So this is the result of lowering the price every single time. Now, when we go from here, right, you can see pretty clearly the price effect is going to be negative 80 because we go from positive 50, which is what we gain by selling the fifth unit, right? This corresponds to the fifth unit, positive 50. But at the end of the day, we have negative marginal revenue, and that means that the price effect has to be outweighing the quantity effect here, and that's why our marginal revenue is negative. We can test that and see if it's negative 80. When we cut the price from the fourth to the fifth unit, we cut it by $20, but we cut the fourth unit, the third, the second, and the first by $20, so 4 times 20 is negative 80. Okay, part B. So I guess that one actually wasn't that bad. It was maybe understanding what they're asking you. Oh, it actually isn't part B. So we did B, we did C, we did D. Part E says what additional information is needed to determine their profit maximizing output. Well, we have no idea what their costs are, so like what their marginal cost is. And that's just number one. Number two says replicate figure 61.3 and use your graph to show what happens to the following when the marginal cost of diamond production goes from 200 to 400. Use the information to identify specific numbers for prices and quantities on your graph, blah, blah, blah. So let's go back and look at 61.3 and see, that is 61.3. So in this picture, we're going to replicate that picture on our paper, and then we're going to show what happens when the marginal cost goes from 200 to 400. So it's just going to move up to 400. So graph, quantity, price, and this is our demand curve, which is the price that we're going to find out. Here, that's marginal revenue, and we'd say this is the 200, and that's our marginal cost for the supply curve for the firm. We know that they are producing at this quantity, which is, it says 8, and their price is up here on the demand curve, and so their price is 600, and so that's just kind of the situation beforehand. And it says this curve, this marginal cost, this was in the original problem, is going to shift up to 400. So we'll say MC1, supply 1, 400. And we know that now they're going to produce MC and MR. They'll produce here at that quantity, which we don't know what that is yet. And we know that they will price up here, which we don't know what that price is yet, but we're gonna find out what those are. And so it says, let's go scroll down here. It says, so the marginal cost went from 200 to 400, so we did that, and it says use the information in table 61.1 to identify specific numbers for the prices and quantities in our graph. And we did marginal cost curve, so I'm just gonna say part A, done. Part B, profit maximizing price and quantity. We're gonna look that up in that table that it specifies. The profit of the monopolist, we can find, it tells us in the original graph, it said that this is also the ATC. And so we'd say that that's ATC1. So we know that this area, whatever this is going to be our profit. And so we still need to know like that and that. And then it says the quantity that would be produced if the diamond industry were perfectly competitive and the associated profit. So if it were perfectly competitive, they would be, so we're going to do C in a second. D, it would be where supply and demand intercept, and so that would be here, right there would be perfect. And it's asking for like what the associated profit would be, but the profit would be 0 because that's the ATC level as well. So if this was like the price were 400 and we were producing at this quantity, whatever that is, then the profit would be 0. Okay, so let's go and check out what those numbers are from table 61.1. Sound effects, this table? Yep, this is. Okay. So what we're going to look for is basically we have a quantity of diamonds that's less than 8. And we're looking for basically where the price is going to be like higher than 600. And so for one of these, let's take a look here. I'm trying to remember these. This is one's kind of quirky. So 800 for. I'm going to double check actually and just see like what this graph even looks like, see if they're giving us additional information. They don't. That's interesting. So we were at point B. So, all right, let's take a look here. I'm just going to say like, let's just call it 6 and 7. 6 and 700. That's probably not right, but I'm just picking a number and just let's get this over with. So at that level, right, then you can see, oh, it actually does tell you marginal revenue. So what's the marginal revenue at 6 would have to be 400. So 6 is, yep, it's right in between the two. So that's where we actually need to be. So actually, I guessed correctly. That's cool. So the reason why this is correct, right, is look for where we know that marginal revenue has to be equal to 400 at some quantity that is here, right? And it happens to be like right between these two values. So that corresponds to quantity 6 and 700. So I managed to actually just guess it by just picking a number smaller than 8 and with a price higher than 600. So from this, we know that the profit is 7 to 4 is 300 times 6. So profit is 1,800, right? As opposed to if it were perfectly competitive. So, okay, so phew, that one was kind of a doozy intellectually a little bit. All right, scroll back here. Let's do some multiple choice. Let's hope these are a little bit easier. I hope so. Number 1 says the monopolist profit maximizing output, MR equals MC. It occurs at point A, so the output level for that, it looks like 4. So that's B. Number 2 says the monopolist total revenue, so it's whatever the price is times the quantity. We know the quantity is 4, and the price at point B is 60. So 4 times 60 is 240, which is C. Number 3, the monopolist total cost. So whatever the ATC is at 4 units, because that's how many units we're producing. And so we're looking for ATC times the quantity, because then that'll just clear out the average and just give us total cost. So it's 20 times 4, which is 80. So that's B. Number 4 says the monopolist is earning a profit equal to, and that's just the difference between total revenue and total cost. So you could say 240 minus 80 is 160. Or you could calculate 60 down to 20. So it's this 60 to this 20 and over. Either way, it should give you 160, which is D. And number 5, how does a monopoly differ from perfect competition? It produces a smaller quantity. That is true. We know that, right? That's the idea here. It charges a higher price. That is true, right? That this would be the perfectly competitive price, but we know they charge way up here. And it earns normal profits in the long run. No, it does not. The perfect competition firm does, but the monopolist does not. So we'd say 1 and 2 only. That is part D. Let's take a look at free response number 2, coming in for a landing. All right. Number 2, draw a graph showing a monopoly earning a normal profit in the short run. Can a monopoly earn a normal profit in the long run? Explain. Sure. Yeah, that's actually kind of a silly question, but all right. It doesn't tell us how to draw it, so I'm just going to draw the simplest monopoly that we can. Marginal revenue and marginal cost equals the supply curve. And so we know they produce at MR equals MC, right? That's the quantity, Q star. And they price up here on the demand curve. So we'll say that's P star. It's supposed to be a dotted line, sorry. And then it says normal profit. So normal profit is price equals the ATC at Q star. So we'll just have our ATC come down, hit the minimum at the marginal cost, and then come back up again. And so that's a monopolist earning a normal profit in the short run. That would also be true for the long run, right? Yes, because they just can't, I don't know how to explain why. They could, if the market, demand curve stays the same, I guess. It's kind of a weird question to justify like why this could be, but basically, if it's true that it could do it in the short run, it can do it in the long run. It would be unusual, you know, by definition, it would be a little strange for a monopolist to do that. It would just be a total coincidence. There's no like rule that says in the long run monopolists have to earn normal profit. There is a rule like that for perfect competition because firms can enter and exit. But in the long run for a monopolist, you know, it's like, I guess they could be, but it would just be a coincidence. All right. Hopefully this helps you. I'll see you next time.